Okay, so in the previous lesson, we've looked at your Pythagoras, okay? In some of the questions that you'll do moving forward with measurement, you will be using a little bit of Pythagoras, okay? Some of the questions might incorporate using this, so please don't forget it. Don't treat it as a separate thing. Incorporate it in your other questions where triangles might be involved, okay? So just think back to this when we do some of these questions, okay? Now we're going to look into your composite shapes. All right. Does anyone know what the word composite means? You know what that means? Composite. Composites. Jamie, do you know what composite means? Maybe face the front so you can answer it properly, yeah?
Oh, no.
Yeah, what does composite mean?
Like, not symmetrical.
Oh, not.
No.
Not quite, but.
Two shapes put together.
Okay, good. Thank you, Danvi. Composite means normally in the context of maths or with measurement, two shapes put together. Okay, so you might have like a circle and a rectangle put together, or half a circle and half a square put together. Okay, or you could have a triangle on top of a rectangle. Okay, composites, basically two shapes but put together. Now we're going to focus on area. Okay, area. Okay, if you have forgotten what that means, is basically the space or the space of a shape, or the space within any 2D shape. Okay, so if you put these together, what you're trying to look for is the area of two shapes. Okay, that's all this is. So if you can find the area of one shape, area of another shape, put them together, you're basically doing area of your composite shapes. Okay. So as our learning intention, what I would like you to be able to do by the end of today's lesson is basically calculate the area of your composite shapes. All right. If you can do that, I will be happy. And there are a few shapes that we're going to look into. So most of them are just going to be basic 2D shapes. So nothing too crazy, just your basic 2D shapes. So you're going to be able to calculate that, I hope. Identify as well the dimensions. So when you talk about dimensions, we're talking about the side lengths of these shapes. Okay. And determine missing dimensions. So you would have done a little bit of that in the previous chapter in 6B, finding out the unknown lengths. Like I'll pull up maybe a quick example here of it. So go here. All right, so in 6B, when we looked at some of these triangles, some of you would have had to find or think about what are some of the missing lengths in these shapes. Like for example here, okay, if I try to find the unknown side lengths for this shape, sorry, oh, it won't let me edit, that's all right. But for this shape here, for example, if I'm trying to find out the length of this side of the triangle, because I can see there's a triangle there, plus this side, I know that this whole thing is 3, and this bit here is 1.9. So logically, if you want to try and find what this length is, you'd go 3, take away that 1.9, and you'd get that length. Same with this side. If this is all 3.5, that bit there is 1.7. To get this length here, AB, you'd go 3.5, take away the 1.7 to get that little side length there. Yeah. So that sort of reasoning is what you'll use when you're trying to find out the side lengths or the missing dimensions of different shapes. And obviously, finding the area of them is the big ticket item, which you need to be able to do. All right, so let's start with this. And the reason why I want to start with this, converting units, is because some shapes are not going to have the same exact units. Okay, and what I mean by that is you might have, for example, a triangle. And Mr. Torrio might pull a dodgy on you and say, hey, this is 2 meters, but this is going to be 3 centimeters. Okay, now, if you think about it, this isn't to scale. That's fine. But if you look at the lengths, they're not the same units. Okay, so if you went ahead and did, oh yeah, length C, that's going to be square root of 2 squared plus 3 squared, and whatever the answer is that going to be right or wrong? Why? Yeah, the units aren't the same. This is 2 meters, so logically, if I was to draw this in scale, this should be like really long, and this would be like really short here. Okay, the lengths wouldn't match up in terms of the answer that we get from, okay, doing that formula. Okay, so we need to be able to actually figure out how to convert or make these two, okay, the same. Make them both meters, make them both centimeters, whatever we want. Okay, you probably have all seen this before. Okay, you've seen these converting units between kilometers, meters, centimeters, and millimeters. Most of the stacks that we give you will only incorporate this. We may or not, we probably won't give you any like yards or feet to convert at the very least. Okay, but we'll just be using these. So if you look at these, I can see that when I'm trying to convert from one unit to the other, okay, these numbers up here will help you understand how to get there. So if, for example, I'm at kilometers and I want to convert something to meters, okay, looking at the arrow, it says the number of that kilometer, you need to multiply it by 1,000. Okay, so let's say you've got, I don't know, 3 kilometers, okay, and I want to change it to meters. Okay, that means to change it from kilometers to meters, I'm multiplying by 1,000. So 3 times 1,000 will equal 3,000 meters. Okay, if I want to go from, let's try another one, meters. So let's say you got 20 meters and I want to change it to centimeters. Okay, so to go from 20 meters to centimeters, you're multiplying by 100. So 20 times 100 will equal 2,000 centimeters. Okay, and it works the other way as well. If I want to go from millimeters to centimeters, okay, let's say I'm at 56 millimeters, okay, and I want to transform that to centimeters. Okay, so to go from millimeters to centimeters, you're dividing by 10. So that's going to be 56 divided by 10, okay, which equals 5.6 centimeters. Okay, I'm just calculating these in my head, but if you're struggling with that, please use your calculators for it. Okay, so follow these principles when it comes to going between units. I'm going to do one more example. Let's say I want to go from millimeters to meters. Okay, what am I going to do then? Okay, and it's going to be the same principle when you're transforming meters to millimeters or kilometers to centimeters. So what I'm actually doing is I'm taking more than one step to go from one unit to the other. So if I want to go from millimeters to meters, that number, I have to divide it by 10. Okay, and then after that, divide it by 100. Okay, so let's say you've got, I don't know, 250, actually let's go 2,560 millimeters. Okay, let's go with that. And I want to change it to something meters. Okay, so if I want to change that, so 2,560 millimeters all the way to meters, I am dividing by 10 and then dividing by 100. All right, so you can use your calculator for it. It's a lot quicker actually, but if you can do it in your head, the answer will be 2.56 meters, but 2,560 divided by 10 and then divided by 100. Okay, 2.56. So that would be equivalent to 2.56 meters. Does that make sense? Okay, I'm going to get you guys to do these ones for me. Convert these units to what it asks you to. Okay? Okay, so at the start of this session, so session 2, we looked at understanding what does the words area and composite mean. That's right. I'm just going to wait for those two. Boys, are we listening? Jeremy, Jacob, listening please. Dunby, you guys are in the recording now, so all of YouTube's going to hear. Make sure you're listening. So at the start of this session, okay, we looked at trying to understand area and composite. So if you put those two words together, it's all about finding the area of two shapes that are put together. Okay? So a composite shape, if you gave it a definition, is basically a combination, okay, of simple shapes. That's all it is. So if it's essentially just a combination of simple shapes, finding the area means just finding areas of those simple shapes and then adding them together. Okay? And that's in a summary what this all means. Okay? Calculating the sum of the areas, okay, adding it all together. But also, one of the tactics that you can use is finding the area of a large shape and then subtract the extra area that you either need or you don't need, okay, depending on the question. All right, so most of the shapes that you work with, you just got to be good at understanding or looking at it and saying, all right, it's going to need this formula or that formula, okay? I'm going to hand this out to you now, and we're going to go through a few of the shapes that you're going to work with. I've given you the formulas on it as well, so let me just open it for you, what it looks like. So it's this. I'm going to go through this together. And I would like you to please put these in your bound reference, okay? These shapes are going to come up in your SAC multiple times. And then you're going to keep asking me, so what's the area or the formula for this shape? And I'm going to tell you, look back at that sheet I gave you. And I'm not going to print these again, yeah? So make sure that you stick these in your bound reference. All right, so just going through these shapes real quick. It won't take you very long, yeah? Most of these shapes you've probably encountered in your previous years of studying measurement. The first one is a square. If you look at the shape of a square, okay, all the sides are going to be exactly the same. And that corresponds to the formula, length times length, okay, because it's exactly the same. It can be simplified to length squared, but I find that most of you guys just prefer to use this. That's what I've learned in the past. So what I want you to do is for this shape, make an example of using the formula for finding its area of a square. So always draw your shapes. Always draw your diagrams when you work with measurement. So let's say, for example, I'm going to write the length 4 there. In any shape that you use, okay, or in any shape you're working with, whenever you see these lines, it means that they're exactly the same length. Okay, so when you see just the one number and then a bunch of lines like that through the sides, it means that they're all 4. Okay, I'm going to give this maybe a unit of 4 centimeters. Okay, so when we work this out, the area is going to be L times L. So that's 4 times 4, which equals 16 centimeters. Now, whenever you do area, always put squared. Okay, for area. All right. When you do volume, what do you use? Cubed. Okay, good. So just understand for area, it's squared. Okay, I'll show you another one real quick. Rectangle, same deal. Draw your diagrams. And you can use any units you want, but just keep in mind with a rectangle, slightly different, right? You've got length and width on any rectangle, and sometimes you'll find that it's denoted as well with some of these lines. So these lines, again, mean that they're the same, but just watch out for number of lines on some of the sides. So for this one, the lines that have the single hash through it means that they're the same. And these ones that have 2 means that they're the same, okay? Just keep that in mind. So you might find that, for example, I might say that this is 5 and this can be 3. Okay, so when you're finding the area for it, look at the formula, length times width. You know, on any rectangle, most of the time, kids get them mixed up. Okay, it's not too big of a deal if you call this length or if you call this width, but just for a rectangle, understand, okay, that it doesn't really matter too much. Let's just say that's length and that's width for now, because you'll find shapes, you'll have to turn your head a few times and then the length and width gets a bit muddled up. Okay, but just understand on a rectangle, that's the formula for it. So the area, L times W. Okay, so that's going to be, remember, L. So that means this L is the same as that. So that means the length is 3 and the width is 5. And I'll give it, let's call it kilometers for today. So that's going to be 15 kilometers squared. All right. The rest of this should be pretty straightforward. I'd like you to have an example for each one in your sheets. Okay, so do your diagram for each one, and then do the formula for it to find the actual area of that shape. Okay. Don't use you can use my ones, but you can make up your own if you like. Last lesson, we started looking into finding the areas of composite shapes, and even before that, we were looking at converting units from meters to millimeters to centimeters and kilometers, and then after that, we looked into areas of these really simple shapes. And I hope again that you put this in your notes because you will be referring to this in this lesson. Okay, so we looked at areas of squares, rectangles, triangles, a rhombus, which looks like a diamond, parallelogram, a trapezium, a kite, which again looks like a diamond, and then your circle, and then two types of the radius, sector areas. Okay, because the reason why I included this Pac-Man shape is because I've seen this come up in exams and SACs before. So you just want to be aware of how this works. Just make sure you understand how the formulas work as well and what each part of the formula is referring to. Like, for example, on a square, L and L are obviously both the lengths, okay? On a rectangle, it's length and width, okay? So one side is the length, one side is the width. It can change on a rectangle, but that's fine. Triangle, you've got two things. You've got the base, which is one length on one side, and then generally the height of the triangle, okay? So most triangles will always use this formula, but sometimes you might come across different types, but for now, that's it. A rhombus, sorry, looks like a diamond. So it's got an A and a B length. Just understand that. And then that's the formula for it. For a parallelogram, you've got a base and you've got the height. Notice how with a parallelogram, it's on a slant. Okay, so parallelograms, all the lines are actually adjacent in that, like they're also parallel. Okay, that's why it's called a parallelogram, and it's on a slant. All right, trapezium looks like that. So it's kind of like that kind of shape. I don't know how you describe it, but it's like a boat, but upside down. Okay, that's what it looks like. There's an A length, a B length, and there's always a height. So that's how you use the formula for it. Just copy it as you see when you put it in a calculator. You should be okay. Kite is the same actually as a rhombus, so that's fine. Circle is probably the main thing. So on the circle formula, pi times radius squared, the r is the half length of that circle. Don't get it confused with the diameter. So diameter is the full length. Okay. Sector, for the formula of it, you have to look at the sector of the circle that you're looking for. So for example, here, I'm looking at this pizza. That means I'm using the angle in the pizza. Okay. Different to, let's say, for example, looking at this shape, the Pac-Man shape. I'm looking at the Pac-Man shape, not the pizza shape. Yeah. So that means I'm focusing on this angle. Okay. Last lesson, I think Jordan said that a full circle is how many degrees? 360. So if that's 70, what should this angle be? 290. Okay, so be aware that the angle there that you're focusing on is 290. Cool. All right, let's get into the bulk of what we're doing. So we're going to try and find the area of these shapes. Okay. Shape A. Okay. Can anyone tell me what kind of shapes would you be working with in shape A? Composite, remember, means two shapes put together. Okay, so what two shapes could you be working with? Nelson? Square, and maybe the other person, Jeremy? Semicircle, sorry. Jacob, wrong person. I get you guys confused, man. So a square and a semicircle. So what I like to do is you break this up into two shapes. So one shape is a semicircle. You don't have to draw them, but for some people, I think it helps to visualize it. So draw your semicircle like that. And you know that for this semicircle, there's a few lengths that you have to try and find because it doesn't show you explicitly here what is the radius. So if you know that this bottom length here is the same as this bottom length, and how do we know it's the same? Look at these little lines. They're all the same. So if this is saying that this is 5, this must also be 5. And so because this is 5, this whole length here must be 5. Okay, now that's not actually the radius of the circle yet. The half length of this semicircle, the full length of this is 5. But if you want the radius, which is only half of it, Junior, what's half of 2.5? Oh, half of 5. What's half of 5? 2.5. Okay, so that means this half here is 2.5 for the radius. All right, so there's my circle. I can now find the area of it, but let's not do that just yet. Let's finish doing the full diagram. So that's my circle. What about then the square? Okay, so this square here, just draw it out again. It helps to, again, visualize it. So the square just has a length of 5 here. So if it's 5 there, these lines mean that they're the same. So that means the length here is also 5. Okay, easy. So now you can refer to, if you want, okay, you can refer back to this to look for the formula that you're going to need. Okay, but I don't think it's too hard to remember. So looking at this one here, this circle, the formula for any circle is pi times radius squared. Okay, any circle. So in this case, it's going to be pi times 2.5 squared. Okay, and that will give us, on my calculator, pi button, if you didn't know, is this. This is down here next to that 10 times. So, but you got to press shift or second. So pi times the radius of 2.5 squared is this button with an x2 there. 19.63, let's say that. Okay, now the tricky thing is this circle is not a full circle, yeah? As Nelson mentioned, it is only half a circle. So what do we need to do with this answer? Half it, yeah? So divide it by 2. Therefore, that area is, divide by 2, 9.82. Okay, let's just round it to that. Doesn't have any measurements, I think. Oh, it's centimeters, so let's call it centimeters. So centimeters squared, okay? That's one shape. Now, the other shape you have to add is that square. So let's add that square. That square shape, as you can see, remember for a square, the area is length times length. So it's going to be 5, so that's L, and that's L, yeah? 5 times 5, which equals 25. And there's nothing important or tricky that we got to do. It's just a normal square. So if we put these together, okay, adding them up, that's going to be 9.82 plus, I like colors, yeah, 25. And that will equal, all up, 34.82 centimeters squared. So that's the total answer there. 34.82. Really easy, yeah? Most composite shapes, you don't actually have to go through this whole process. If you can already do it in your head, or at least understand what formulas you need to use, just chuck it in your calculator and do it. But show a little bit of working out. You don't even need to draw the shapes if you don't want to. You just go straight to this, if that's easy. But if you like drawing the shapes, please do it. Okay, a lot of you guys I know are visual learners, so visually represent it so it's easier for you. All right, let's go to the next one, next shape. I'll leave that up there so you guys can see it. Okay, Claudette, can you tell me what 2 shapes can you see in this one here that you need to look for? Good, a rectangle and a triangle, easy, thank you very much. All right, so let's break it up. You've got a rectangle. Okay, you can draw the dimensions. You know that this is 4 because it says here. Okay, that's 4, and you know that this is 7. Okay, because it says up here that it's 7. So that's easy enough. 4 and 7. Okay, what about the triangle then? Okay, you can redraw it again, but if you don't want to, you don't have to. So here you've got a funky looking triangle with these lengths. All right, so for this triangle, even though it is upside down, its base is actually 7. Okay, do we know why? Because this here will act as its base. Okay, so that's 7 because this is 7. All right, now what about its height? Good. Okay, how did you get 6, Jade? Okay, so she went 10, take away the 4 to give me this. Okay, so thank you very much, Jade. Definitely 6. Okay, so sometimes you'll have to do that for some of these shapes. So you know that that's 6. All right, so area of a rectangle, really easy. It's length times width. Okay, so it's going to be 7 times 4, which equals 28 meters squared. Easy. For a triangle, if you forgot the formula, again, look at the sheet that I gave you. But the formula is base times height divided by 2. Okay, so that's going to be a base of 7 times a height of 6 divided by 2. What's that? 42 divided by 2 is 21 meters squared. Okay, nice and easy. It's not too hard, I think. And then from there, add everything up, right? So you're adding these two up. 28 and 21. So it's 28 plus the 21. And that will equal 49 meters squared. Easy. Okay, not that hard. So it's all about breaking it up, figure out the formula for each shape, and then just put them together. Okay. Now that's one part of it. The other part, oh, are we still copying? Okay, let's keep going. The other part now is, what about this? This one's a bit different. The solutions are already there, but this one has a couple ways of doing and finding the shapes. Now, Anyone want to tell me what shapes can we use for this? That's right. 2 rectangles in a square. Very nice, Jacob. Did I get it right? Jeremy. Jacob. Oh my gosh. 2 rectangles in a square. So you're telling me you're going to cut this rectangle here and here as well. Is that correct? Is that what you're thinking of, Jacob?
Yeah.
Okay, cool. Anyone else? Any other suggestions of what we could do? Any other suggestions?
2 squares and a rectangle.
So you're saying that. Okay, that's definitely one way too. But there's a third way, an easier way. Anyone want to tell me? There's an easier way. Or did you have it? What do you think it might be? Say it. It's all right. If you get it wrong, it's okay.
So like you add like a bit in the middle and take it away.
Okay, so what are the 2 shapes then? Basically, 2 rectangles, yeah? You've got a big one. So find the area of the big rectangle and then take away the little area. That's it. All right, so let's do that then. So the big rectangle, okay, I'm going to draw it for you. You don't have to draw them, okay? It's not always beneficial to, but I will do it. So the big rectangle, can anyone tell me the dimensions? You know that the bottom is 10. Okay, what about the side? Yes, Ruby. Why is it 16? 9 plus that 2 plus that, well, actually, is it 5 here? I think it's 9. Yeah. So 9 plus 2 plus 9. Did you say 9 or 5? Okay, so it's 9, yeah, because this says it's 9 here, and it should be the same as here. So 9 plus 9, which is 18, plus 2 is, so that side length is 20. Now, that's one part of it. The other part is we have to take away the little one, which is this. So let's draw it. The little rectangle is a dimension of 2, and that bottom here is 5, because that's 5 there, and that's 2. So if you just find the areas of it, all right, this is length times width. That's going to be 20 times 10, which equals 200. Minus, okay, the area of the little one, which is, again, length times width. So that's going to be, let's go 5 times 10, which equals 50. So the shortcut for this is, instead of adding 3 shapes together, it's easier to actually take away. So it's going to be 200 minus the 50. And that will equal 150 centimeters squared. I think that's easier, right, than breaking it up into 3 shapes. So those are things that you got to think about when you do this. Yes.
How'd you get 50?
How did I get 50? 5 times 10. Oh, sorry. 2 times 5. Oh my gosh. Thank you for calling me out on that. 2 times 5. Oh my gosh, it's the afternoon. Okay, let's fix all that up then. I was testing you. I was testing you. So it's 190, sorry. My bad, my bad. Thank you for calling me out. But do we get that? It's actually easier to do this rather than break it up into 3 and then add them all up, because it's clearer to just go, oh yeah, it's this big one minus that little tiny one there. And that's it. Okay, now the next few questions are going to be annoying. Ooh, I want you guys, maybe with the person next to you or with somebody, to find the area of one of these shapes. You can pick any one. Okay, I'm going to give you like 10 minutes, maybe 5 minutes. Find the area of one of these shapes. Okay, see how you go. Just pick one